Today our objective is to be able to rotate figures in a coordinate plane. As we get started, let's review what the quadrants are and how they're numbered in a coordinate plane. The top right quadrant is quadrant 1. We use Roman numerals to name our quadrants. So this is 1, top left is 2, bottom left is 3, bottom right is 4. So it goes counterclockwise. This is 1, 2, 3, and 4. Today when we rotate or turn our figures, sometimes we'll go clockwise, which would be the same as the hands on a clock. And sometimes we're going to rotate our figures counterclockwise, which would be the opposite of a clock. The first picture says rotate. If the picture is rotated 90 degrees counterclockwise, which quadrant would the new picture be located? Well, if I look at my quadrants, this is 1. The picture right now is in quadrant 2. This is 3, and this is 4. If I rotate it counterclockwise, that means I'm going the opposite of a clock. So a clock would go this way. I need to go the opposite way, and I need to only go 90 degrees. So if I start at the foot of this picture and draw a 90-degree angle, this picture would rotate to quadrant 3. So the new picture would be in quadrant 3. If I look at the next question, it says, if triangle ABC is rotated 90 degrees clockwise, which quadrant would the new triangle be located? So here's quadrant 1, 2, 3, and 4. Right now the triangle is in quadrant 2. I'm going to rotate it clockwise, so the same as a clock. So if I go the same as a clock, it's going to rotate this way like the hands on a clock. 90 degrees. If I draw a segment from point C to the origin and then try to make a 90-degree angle, my new point C, C prime, would end up in quadrant 1. So the new figure would be in quadrant 1. If triangle ABC is rotated 180 degrees, which quadrant would the new triangle be located? So this is quadrant 1. That means the original triangle is in quadrant 2. This is quadrant 3. And here we have 4. This time we're going to rotate it 180 degrees. So if I draw a straight segment from point C to the origin, I'm trying to make a 80-degree angle. That's the same as a half circle. Here's a 180-degree angle. This problem didn't tell me clockwise or counterclockwise, because it doesn't matter whether I rotate it clockwise or rotate the triangle counterclockwise, I'm going to end up at the same spot. So the new triangle would be located in quadrant 4. If triangle ABC is rotated 90 degrees counterclockwise, which quadrant would the new triangle be located? You try this one. Okay, let's see if you're right. Here's 1, 2, 3, and 4. So we're going to go opposite of a clock, and we're only going to go 90 degrees. So if you said quadrant 3, you were correct. If rectangle QRST is rotated 90 degrees counterclockwise, which quadrant would the new rectangle be located? Try this one. Okay, let's check. Here's quadrant 1, 2, 3, and 4. So the rectangle right now is in quadrant 4. If we go opposite a clock and only rotate 90 degrees, it would be quadrant 1. Next question. If rectangle QRST is rotated 180 degrees, which quadrant would the new rectangle be located? Try this one. Let's see if you're right. Right now, this rectangle is in quadrant 4. If I rotate 180 degrees, it does not matter whether I go counterclockwise or I go clockwise, I'm going to end up in quadrant 2. Quadrant 2 is the answer. If rectangle QRST is rotated 90 degrees clockwise, which quadrant would the new rectangle be located? All right, let's see if you're right. Right now it's in quadrant 4. If we go 90 degrees the same as a clock, this is the way the hands on the clock go, and if I rotate 90 degrees, make a 90-degree angle here with point Q, it would be quadrant 3. All right, our next problem says graph triangle XYZ with vertices X is at 2, 2. So I go right 2 up 2, here's point X. Y is at 6, 2, I'm going to go right 1, 2, 3, 4, 5, 6, up 2, here's point Y. Z is at 6, so go right 6, up 5, here's point Z. So here's my original rectangle, or triangle. I'm trying to draw straight lines. Sometimes it's hard with this airliner. Okay, so I got my original triangle. I'm going to rotate it 90 degrees counterclockwise about the origin. So I'm rotating it around the origin. I'm going 90 degrees, the opposite of a clock. So the opposite of a clock would be this way. So if I start at point X and I draw a line from point X, a line segment, to the origin and try to get a right angle here, my new point X, X prime, looks like it would be at -2, 2. If I tried to do the same with point Y, here's point Y, I'm going to try to draw a line segment to the origin, and then I'm going to try to make a right angle. So let's see, I'm going to the origin, I'm trying to make a right angle from point Y to the origin to find my Y prime. So as I do this, okay, so I'm trying to make my right angle for point Y, and I'm going to go like this to get a right angle. It looks like my original point was at 6, 2. My new point is going to be -2, left 2, and up 1, 2, 3, 4, 5, 6. So when we do this rotation around the origin, the line segment from point Y to the origin should be the same length as the line segment from the origin to my new point Y, Y prime. If you do your rotations with paper and pencil, it's a little easier to measure how long these are to get them the same length, plus to make sure you have a right angle. Whenever we do rotations around the origin, there is a pattern with your X and Y values. So I'm noticing like my original point Y was 6, 2. My new point Y is -2, 6. So what happened was my X value in my original point was 6. It became my Y value in my new point Y. My Y value in original point Y was 2. It became my X value, but I took the opposite. So if I follow that pattern, I think that the new point Z, Z prime, the X value here is 6. I think the Y value will be 6 in my new point Z. My Y value was 5. I think the X value will be the opposite of 5. Let's see if -5, 6 looks like it would make a right angle. If I start at Z, go to the origin, okay, and then try to make a right angle. Now I know my line segments aren't the straightest. It's sort of hard on an airliner, but if you were doing this on a paper, you would make sure that this length of this line segment from point Z to the origin is the same length here, okay, and this should be at -5, 6. All right, so if I connect my points, this is Z prime. So z prime, y prime, x prime. This new triangle, which I'll go over in black so you can see a little better, should be the same size and same shape of the original blue triangle here. And there's always a pattern, okay, to help you find the correct points when you rotate around the origin. All right, let's look at the next one. It says graph triangle XYZ with vertices X is at 1, 2. So if I go right 1 up 2, here's point X. Y is at 4, 2, right 4 up 2. And Z is at 1, negative 3. So here's my Z. So it looks like my original triangle is a right triangle. But this time I'm rotating it 90 degrees counterclockwise about vertex Z. So not about the origin, but rotating this figure around point Z. So I'm rotating it around point Z. What that means is Z is going to stay where it is. So my new point Z is actually going to be 1, negative 3. Z prime is at 1, negative 3. Now I need to find X prime and Y prime. So I know I'm going to rotate counterclockwise, the opposite of a clock. So this way, 90 degrees. Well, right here, I should make a right angle. If I go from point X straight down to point Z, I'm noticing this segment is 1, 2, 3, 4, 5. So the new segment should be 1, 2, 3, 4, 5 units long. Here's X prime. So X prime looks like it's left 1, 2, 3, 4. So it's negative 4, and it's down 3. So negative 4, negative 3. If I do the same with Y prime, to find Y prime, what I need to do is draw a right angle. So I'm going to start at Y and go to Z. And I'm going to try to draw a right angle. So I'm drawing a right angle from Y to Z, and I'm trying to make this line segment from point Y to Z the same as this line segment for the other side of my right angle. These are a little harder when you do it with an airliner on a screen. A little easier if you have paper and pencil because you can measure how long the line segments are. But this looks like it's a right angle. If I measured this length, it would be the same as this length, and this would be my Y prime. So this would be my new point Y. It would be at negative 4, 0. When you rotate around a different point other than the origin, like in this example, I rotated around vertex Z, there's really not a noticeable pattern. All right, let's look at our next one. Graph polygon TUVW with vertices T is at negative 4, 2, so I'm going to go left 4, up 2. Here's my original point T. U is at negative 3, 4. V would be negative 1, 4. I go left 1, up 4. And W is negative 1, 2. So here's my point W. If I connect, I'm going to get a trapezoid. All right, and what I'm going to do with this figure is I'm going to rotate it 180 degrees about the origin. So it really doesn't matter whether I go clockwise or counterclockwise. I'm going to end up in the same spot. Right now I'm in quadrant 2. When I rotate it 180 degrees, I should end up in quadrant 4. So if I start with W, I'm going to go straight through the origin. And let me try that one more time to make a straight line. I'm going to go straight through the origin. Okay, and these line segments should be the same. Okay, it looks like my new point W, my W prime, is going to be at 1, negative 2. If I try to do the same with point V, I'm going to go straight through the origin. Okay, it looks like my V prime is going to be at 1, negative 4, because this is 180 degrees. Whether I go clockwise or I go counterclockwise, that's 180 degrees. So I'm trying to see if I find a pattern with this. Let me check this out. So my original point W was -1, 2. My new point W is 1, -2. So it looks like what happened was my x value became the opposite. It was a -1, it's a +1 here. My y value became the opposite. It was a 2, now it's a -2. Let's see if the same thing happened with point V. My original point V was -1, the x value was. The new x value is +1. My y value was 4, my new y value is -4. So if I follow that pattern with U, I would take the opposite of -3 to get +3. I would take the opposite of 4 to get -4. T, I would take the opposite of -4 to get +4. The opposite of 2 to get -2. Let me see if this looks the same. So if I go back, here's my W prime, here's my V prime. If I graph T prime at +4, 1, 2, 3, 4, -2, here's T prime, and U prime at 3, 1, 2, 3, -4, this would be U prime, and connect. This trapezoid should be the same size and shape as the original, which I believe they are. If you look at the original blue trapezoid here, it looks exactly the same size and shape of the green one. What happened is I just took it and turned it or rotated it around the origin. Okay, here's our last problem. Graph triangle ABC with vertices. A is at -1, 1. So here's A. B is at -3, 1, 2, 3, 4. Here's segment or point B. And C is at -4, 1, 2, 3, 4, +1. Oops, I think I went to 5. -4, 1. All right, so this is point C. So I have a triangle. What I'm going to do with this triangle is first I'm going to rotate it counterclockwise 90 degrees about the origin. So here's the origin. I'm going to go the opposite of a clock, so I'm going to go this way 90 degrees. So point A would be the easiest point to start with because it's closest to the origin. If I just draw a 90-degree angle, it looks like my A prime is going to be left 1, down 1, so -1, -1. If I try point C, and I go from point C to the origin, and then try to make a right angle, this would be a right angle, it looks like my C prime would be at -1, -4. And let me see if I can find a pattern here. It'd probably be easier to look at C prime for the pattern because A, both X and Y values are 1s and -1s. But if I look at C prime, what happened was my -4, which was my original X value, became my Y value. My Y value was 1, I just put the opposite to make it -1. So if I do that same thing with point B here, I take my X value, -3, and make it my Y value. And I take the 4, which was my Y value, and take the opposite of it and make it my X value. Let's see if this makes the same size and same shape of triangle. I'm going to graph a -4, 1, 2, 3, 4, -3. This should be B prime. If I connect these 3 points, okay, this blue triangle here, I'm having a hard time drawing a straight line with my airliner, would be the same size and same shape as the green triangle. It's just I took the green one and rotated it 90 degrees. There is a second part to this question. Now I have to translate 5 units right and 6 units up. And then I'll have A double prime, B double prime, and C double prime. I'll have coordinates of my last triangle after my second transformation. So what I'm doing now is I'm taking each of these points and I'm going 5 right, up 6. So here's point A. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is a double prime. It looks like it is 1, 2, 3, 4. So it's the point 4, and it's up 1, 2, 3, 4, 5. So A double prime is 4, 5. If I do the same thing to B prime, if I go right 5, here's B prime. 1, 2, 3, 4, 5. Then up 6. 1, 2, 3, 4, 5, 6. This would be B double prime, which looks like it's at 1, 3. The coordinates would be 1, 3. C prime, I'm going to take that point and go right 5. 1, 2, 3, 4, 5. Up 6. 1, 2, 3, 4, 5, 6. Here's my C double prime. That looks like it's right 4, up 2. And then if I connect the newest triangle, this black one is the same size and same shape as the blue and the green. So the green triangle was my original triangle. I rotated it 90 degrees counterclockwise. Then I took the blue triangle and translated it 5 right, 6 up. I just slid it over, right 5, up 6. These would be my final coordinates and my final transformation.